Pretty neat. And if we speed up time, we can see how those planets orbit. They do orbit counterclockwise as viewed over sort of the north pole of our solar system. So there you go. Mercury, Venus, Earth, and Mars. And this is something, by the way, the nature of these orbits are actually, they're not perfect circles. They're actually ellipses, a kind of a squashed circle. They're pretty close to a circle, but they're very slightly squashed. And you can see that maybe with Mercury. You can see that it's closer to the sun when it's up here near the top, and it's a little further away when it's down there, because it does have an elliptical orbit. And that was discovered by a creation scientist named Johannes Kepler back in the very early 1600s. He discovered that planets orbit the sun in ellipses, not perfect circles as had been assumed previously. And he also figured out that planets, when they're closer to their sun in the orbit, like when Mercury's up here near the top, it orbits a little faster than when it's down near the bottom. And he figured out the exact mathematical relationship there, that how planets speed up when they're closer to the sun and slow down a little bit when they're further away. And you might also notice Mercury is the quickest to orbit the sun, and then Mars is the slowest of the inner four. And Kepler also figured out the exact mathematical relationship between the period of a planet and its distance from the sun. He found that the period squared is proportional to the distance cubed. P squared equals A cubed. Pretty neat. And you might say, well, I don't know. I think I could figure out that those are not perfect circles if I got my ruler out and measured that. Keep in mind, Kepler didn't have a nice computer simulation of it. All he had was a list of numbers recorded by Tycho Brahe, also a Christian, by the way. Tycho had, this is before telescopes had been invented, and Tycho had recorded the positions, especially of the planet Mars, as seen from Earth, and he recorded the numbers there. And Kepler was able to figure out from those list of numbers not only how Mars orbits, but how Earth orbits, because we're on one of these objects watching the other ones move. And that's a complicated problem, isn't it? Because you have to solve two equations at the same time, not just how the other object moves, but how we're moving. Kepler was able to figure that out. I hope you get some appreciation for the intelligence of the man and the amount of work that he had to do to figure that out. Pretty amazing. We reap the benefits of his genius. And Kepler was a very devout Christian, very devout Christian. He believed in 6 days of creation. He believed that God created a few thousand years ago. That was actually pretty common among scientists in the past, but Kepler is one of my heroes of the faith. Of course, we can now go to these objects, and that's pretty neat. So that's the inner solar system there. Now, the outer solar system, the outer planets orbit quite a bit further out from the sun. People find that surprising. A lot of times in textbooks, you'll see the planets lined up real close to each other. They're actually separated by enormous distances. And you can see the outer planets are moving very, very slowly compared to the inner ones. I really have to speed up time, get those inner planets really whipping around there, and then you can see the orbits of Jupiter, Saturn, Uranus, and Neptune. So Saturn takes around 30 years to orbit the sun once, just to give you a feel for it. So that's kind of the way it looks. And this is an overhead view of the solar system. The planets all orbit pretty much in the same plane. I mean, there are very slight differences in their planes, but they're all within a few degrees of each other. So that's kind of remarkable. That's a design feature because it's very stable. It's a very stable configuration. The planets all orbiting in the same direction and roughly the same plane, and that prevents things like collisions, for example. Now, in some textbooks, you'll see the solar system presented from a perspective view like that, and some people think the orbits are really squished because they think that's an overhead view. It's not. It's a perspective tilted view. From overhead, the orbits are pretty close to circular, but not exactly. They're slightly elliptical. So there we go. So let's go back to the inner solar system here. And we'll just take a look at some of the objects that God created. We'll start with the sun. The sun is 99.98% the mass of the solar system. Everything else is 0.02% the mass of the solar system. So there it is. The sun looks kind of like that. And we can zoom in on it too. This is what I studied in my doctoral research at the University of Colorado in Boulder. I studied the sun, and in particular, motions on the surface of the sun, what we call the photosphere, the layer that you see. And you might notice there's this kind of bubbling surface that you have there. And those are called, those objects that you see there are called supergranules, those that kind of bubbling pattern. And each one of those is about the size of the Earth. You might also see some spots there on the sun, which astronomers call sunspots, because we're not very creative. But there they are. Those are cooler regions on the sun. And the sun is about 6,000 degrees Celsius at the surface, whereas sunspots are a chilly 4,000 degrees Celsius at the surface. So they're quite hot too, but they're not as hot as the rest of the sun, and they don't glow as brightly, therefore. If you could separate a sunspot from the sun, it would actually be bright. It would be glowing, but by contrast, they appear dark. And those are places where magnetic fields are penetrating the surface of the sun, preventing convection, which takes the heat from the lower regions and dumps it to the surface. And so the sunspots prevent that convection. They just cool off. And so there you go. So that's the sun. It produces more energy in 1 second than 1 billion cities on Earth could use in an entire year. God has unlimited power. So that just gives you a feel for the power of God. That's just one star that he made. There are billions of others, of course. The sun's about 100 Earths in diameter. If it were hollow, it could hold 1 million Earths. Again, it gives you just a feel for the power of God who spoke that into existence. And it is pretty amazing. And I'm sure you'll all want to read my doctoral dissertation later, so we'll move on. I'm just kidding. You don't want to read that. So the first planet from the sun, Mercury, the closest planet to the sun. And therefore the fastest orbiting. It takes only 88 days for Mercury to orbit the sun. There's what it looks like. It looks a lot like the moon, really. It's just a heavily cratered world. It doesn't have the nice dark maria that the moon has on the near side. But there you go. So that's what Mercury looks like. And we've sent a couple spacecraft to Mercury. We sent one back in the 70s, the Mariner spacecraft, and then more recently we had the Messenger spacecraft to visit Mercury. And so that's why we have these high-resolution images of its surface. Mercury is about 1/3 the size of the Earth, and it orbits 3 times closer to the sun. Makes that easy to remember. So that's about what it looks like. Mercury doesn't have much in the way of an atmosphere. So any object that gets close enough and gets caught into its gravitational pull just impacts the surface, and so you just have craters all over it. And some of those might have been involved in the process. We think God used a little process when he made the planets there on day 4 of the creation week. And so some of those craters might be left over from maybe God made the material and then collected it, and so the craters are the last bits that he collected, perhaps. In any case, because Mercury orbits so close to the sun, the day side, you might notice it's rotating very slowly too. It does rotate, but it takes 53 days to rotate once, 53 Earth days. And its orbit's 88 days, so its day is just a little shorter than its year, amazingly. And because it rotates so slowly and has no atmosphere, that day side just gets baked because it's been seeing the sun continuously for weeks. And the temperature gets up to about 800 degrees Fahrenheit on the day side of Mercury. The night side, however, has not seen the sun for several weeks. And there's no atmosphere to blanket the heat, so it dumps the heat to space, and the night side can get to negative a couple hundred degrees Fahrenheit, so below zero, which means there is one spot, maybe right about there, where the temperature is actually pretty comfortable, right? So if you crash land on Mercury, you want to crash land right about there, right, where it's not quite sunrise yet. You're still getting a little heat from conduction from the day side, but pretty amazing. And by the way, because Mercury rotates so slowly, if you were to crash land there, the only place where the temperature's comfortable, and start running west, you can actually outrun sunrise. Yeah, it rotates slowly enough you could actually outrun sunrise. So you don't dare stop, though, otherwise the rotation will carry you around and you'll bake. So there you go. So if you ever crash land on Mercury, now you know what to do. You heard it here. One of the interesting things about Mercury is it has a magnetic field. And that was a bit surprising to the secularists because magnetic fields decay over time. Magnetic fields are caused by electrical current in the core of a planet. Maybe you've made an electromagnet by taking a coil of wire and touching it to the ends of a battery, and you can make a little magnet there. That's how they work. So Mercury has a magnetic field like the Earth. It's not as strong as the Earth's. But that's surprising because magnetic fields decay over time. Batteries run down, don't they? And so the electrical current should slow with time. It's not a superconducting core. It encounters resistance. And if Mercury really were 4.5 billion years old, as the secularists believe, it should have run out of magnetic energy a long time ago. And so it's a bit surprising from the secularists as to how it still has that magnetic field. In fact, there's evidence that the magnetic field has decayed between when we sent the Mariner probe back in the 70s and then a more recent Messenger spacecraft. It's actually decayed a little bit. So very interesting. That's confirmation that Mercury is nowhere near billions of years old. It's a few thousand years old. And that's what the Bible indicates, because the world was made in 6 days and human beings are made on day 6 a few thousand years ago. So Mercury confirms that. But it reminds us of what the Earth might look like if we didn't have all these life features, the protective atmosphere of the Earth and so on, that prevents debris from impacting the surface to a very great extent. So the little planet Mercury. The next planet out is Venus. That's not what I wanted. Let's go head back out here. Okay, Venus. There we go. Venus is about the same size as the Earth, just a little bit smaller, but pretty close otherwise. And it is enshrouded in thick atmosphere with clouds that permanently block any chance of seeing the surface. And so in the past, secularists thought there might be life on Venus because it's a little closer to the sun. It might be a tropical world with all kinds of exotic plants and animals. Evolutionists like to think that life evolved on Earth. It probably evolved elsewhere, and so they believe there's life everywhere in space, and including Venus. Some of the older sci-fis even would show, life on Venus and so on, and pretty amazing. And secularists were free to speculate because it's permanently enshrouded in clouds, so you can never see the surface of Venus. But we've sent spacecraft to Venus. The Magellan Spacecraft went into orbit around Venus and used radar. Now, radar can go through clouds, and so it was able to penetrate those clouds. And so we now know what the surface looks like. It looks like that. That's a radar map of the surface of Venus. It is a very tortured world, and because of that thick atmosphere, that creates an enormous greenhouse effect that causes Venus to actually be hotter than the planet Mercury, even though it's further from the sun. The surface temperature is about 900 degrees Fahrenheit on Venus. And day and night, it doesn't matter because the atmosphere distributes the temperature you see to the whole planet. Venus is a very slow rotator. Its day is actually longer than its year, and it rotates backwards. You can see it's rotating the opposite way as Earth and Mercury and most of the planets. And that is really perplexing to the secularists because you see in the secular model of how the planets supposedly formed, they supposedly formed from a collapsing nebula. A nebula is a cloud of gas, and as it collapses, it's going to the spin of it's going to speed up like a skater when she pulls her arms in and she speeds up due to a principle called conservation of angular momentum. And if all the planets then formed from that spinning cloud, they all ought to be upright and spinning the same direction and really at about the same speed. And Venus is just exactly the opposite. It's just backwards from the way the secularists predict. And I love that because I think, God has the right to make all sorts of interesting objects out there. And some of them defy our expectations. So Venus is just backwards, and I think God did it that way just to confuse the secularists. So there you go. Again, it's got that thick atmosphere, slow rotating, interesting planet. And those clouds, by the way, are made up of sulfuric acid type compounds. So it's not a place you want to visit. Let's put it that way. The atmospheric pressure is about 100 times that of the Earth. Some of the climate change alarmists like to say, well, if we're not careful, Earth could end up like that. No, it can't, because we only have like 100th the atmosphere of Venus. So there's no way that can happen on Earth. Venus, we don't have the atmosphere for it. Venus does. And the Lord made it that way because those clouds are highly reflective, and they reflect, I think, about 70% of the light that falls on them. So that's pretty good. And that makes Venus the third brightest object in our sky. Maybe you've seen on a clear night, you've looked over west, and you've seen that bright star in the west. That's Venus. Very, very pretty. You got the sun, the moon, Venus, the third brightest object in our sky. So although it's been called Earth's sister planet because it's about the same size, you can see the similarity is overstated. It's not a place you want to visit on your next vacation, let's put it that way. But it does confirm biblical creation by its backwards rotation. Orbits the same way as the Earth, but it rotates backwards. The next planet out, my very favorite, is the Earth. I wouldn't want to live anywhere else. All your friends live there. Earth has the best restaurants of any planet. And that's what it looks like. And what a privilege that we have the honor of viewing our planet. We have pictures of our planet from space. That's pretty neat. Something our ancestors could only have imagined. And Earth is beautiful. It has a unique beauty to it. It's so colorful with those beautiful oceans, liquid water. We think liquid water is essential for life. And so the planet that God formed to be inhabited, the Earth, according to Isaiah 45:18, God saturated it with liquid water. 71% of the surface is water. Pretty neat. And just beautiful, a beautiful world. And it's got that atmosphere that's protective. So objects that come close to the Earth, they tend to burn up in the atmosphere rather than impact on the surface. Earth has a magnetic field that protects us from harmful cosmic radiation that can damage your DNA, cause things like cancer and so on. And that magnetic field is decaying. We've been able to measure that over the last century and a half. Earth's magnetic field is decaying. We'd expect that. And it's interesting because if you run the equation backwards, the Earth's magnetic field in 60,000 years in a hypothetical past would be stronger than that of a neutron star, which is enough to rip the atoms of your body apart. So that puts a pretty tight constraint on the age of the Earth at much less than 60,000 years. And 6,000 years would work really nicely. So that's an interesting confirmation. We think Earth hasn't always looked like this. We think that before the flood, it might have looked something like that. We're still refining our calculations on that. But we think the continents were different before the flood, that they were all connected, and then they were pushed apart during the flood year. And there's different ideas on the exact shape of that, but it's something like that. So pretty interesting. Earth, as far as we know, is the only planet with plate tectonics. Other planets have tectonics and geology, but only Earth's tectonics are separated into plates that can sort of float on the mantle and under certain circumstances can be moved, and we think that happened during the flood year. It caused the continents to move apart rapidly, not over millions of years, and they're not really moving very much today. There's a little bit of leftover energy from the flood, but not much. So there you go. Earth has one moon, which we call the moon. You understand, for a long time, this was the only moon that was known. People didn't realize that other planets could have moons until 1610. Galileo in 1610 pointed his telescope at Jupiter and saw 4 little stars orbiting around Jupiter. Oh, other planets can have moons too. Interesting. Before that, there was just the moon. That's what it looks like. Now, we always see the same side of the moon, this side. Some people think it doesn't rotate. It does rotate. It just rotates at the same rate that it revolves around the Earth, so we always see the same side. The moon goes through phases. That's just the angle between the moon and the sun. So you can see the sun would have to be on the kind of the right side of the moon now, wouldn't it? And as the moon goes through phases, it takes a month to do that. That's where we get our word month. It's a moonth. And so there you go. But the moon does rotate, and if we watch it from space rather than watching it from Earth, you can see it rotating. It really does rotate, so there you go. It just rotates at the same rate. I'm going to rotate the scene there. It rotates at the same rate it revolves around the Earth, keeping the same face toward the Earth. So there's the Earth in the background, kind of neat to see. So here's the far side of the moon. It looks very different from the near side. It doesn't have nearly as many of those large maria. We think there's some good reasons for that. But in any case, again, what a privilege that we live in a time where we've seen the moon from the other side. Again, something that our ancestors only could have imagined, but now we have nice maps of the far side of the moon. The moon has what's called remnant magnetism. It has little bits of magnetic field that indicate that it used to have a magnetic field like the Earth, a global one, but that has decayed away in 6,000 years. But the remnant magnetism is still there, and that indicates that the moon cannot be billions of years old. It is consistent with biblical creation. And I must admit, I've always been sort of fascinated with the Apollo missions, and I think it's amazing that there have been 12 human beings who have walked on the moon, and they looked up and saw the Earth, that little blue spinning marble, knowing that everyone they know or care about lives on that little world. It's amazing. The Earth looks so fragile from space, but there it is. So the moon is actually a design feature. It stirs up Earth's oceans and keeps them from stagnating. And so that's a design feature. Causes tides and the like, so there you go. You can see Earth has polar caps, polar ice caps. It has seasons because it's tilted relative to its orbit around the sun. And that's why we have more daylight hours in summer and fewer in winter. and therefore the summer's warmer than the winter and so on. So that's a design feature too, that increases the habitable zones of the Earth. Now the next planet out is Mars, and Mars is about half the size of the Earth. And although Venus has been called Earth's sister planet because they're the same size, Mars is probably, let me change the surface there we go. Mars is probably really the planet that's most like the Earth, other than it's only half the size. So the gravity would be weaker. You could jump really high on Mars. That'd be kind of neat. But it has features that are similar to the Earth. It has some craters like the Moon, but not a lot. It has a thin atmosphere, and so some stuff burns up before it hits the surface. But it has weather. It has things of that nature. You can see down at the bottom here this large feature that's an enormous valley called Hellas, and it sometimes fills in with fog and looks very bright. This dark feature is called Syrtis Major. You can see these in a small telescope. Earth passes Mars every 2.1 years and comes close to it. And for a period of about a month or two, you can see a lot of these surface features on Mars. It's quite fun to look at. Mars has valleys, canyons. You can see that large feature right there. That's an enormous canyon, much bigger than the Grand Canyon. It's called Valles Marineris, and it's a tectonic fissure. It's where the crust is simply broken apart. It's about the length of the United States, so it is enormous, and deeper than the Grand Canyon, wider, and so on. Pretty spectacular. Mars has mountains. Mars has enormous mountains. You can see these three features right there, and this really big one there. This one's Olympus Mons. This is the largest known volcano. It is a volcanic mountain. They're all thought to be extinct, but they might just be dormant. We think that Mars's volcanoes, we might see them erupt at some point in the future, and that'd be kind of neat. So think about how big that is, though, the fact you can see it from space. It's 3 times taller than Mount Everest, and the base of it would cover the entire state of Iowa. So it is a massive volcano. Mars also has polar ice caps, the northern one's in shadow there. Let me change the time a little bit. There we go. So there's the northern polar ice cap, just like the Earth. And because Mars is tilted about the same as the Earth, Mars has seasons like the Earth does, although the overall temperature of the planet's colder because it's further away from the sun. But Mars has seasons. They last twice as long because its orbit's longer. But you can see the polar ice cap there, and it shrinks in summer and expands in winter. It's not just water ice, though. It's mostly carbon dioxide, frozen carbon dioxide, dry ice. Mars does have water ice as well, but a lot of carbon dioxide, a lot of frozen stuff there. Mars has 2 moons, and they are tiny, called Phobos and Deimos. Let's go to Deimos first. Deimos is the outer of the 2. And it's not quite round, you can see there. That surprises people. They think moons are round, but only large moons are round. The smaller ones tend to have kind of a random shape. This moon is less than 10 miles across. So it's basically a big boulder orbiting Mars. Pretty neat. And to me, it looks like a potato. So there you go. So that's the outermost of the 2. And then we have the inner moon, Phobos. Phobos is slightly bigger than Deimos. And Phobos also has kind of a random shape. So there it is. About 10 miles across, which means you could walk around that world. That'd be a nice little hike, right? You could probably do it in a day. And wouldn't that be a spectacular view? To be on Phobos orbits really close to Mars. So you'd look up in the sky. If you're on the Mars-facing side of Phobos, you could look up in the sky and see Mars, and it would be enormous. That would be, I don't know, that would be a weird feeling, I would think, to look up and see that. So there you go. It's pretty neat. The gravity on Phobos is very weak because it's so small. Gravity is proportional to the mass of the planet. And so on Phobos, the gravity is so weak, you could pick up a rock and throw it into orbit. You could watch it go over the horizon, and you better duck or it'll hit you in the back of the head because it's going to come up. You could play catch with yourself. You could throw it that way and then wait for it. Kind of neat, these situations that, we can't really comprehend that on the Earth. So there it is. The Mars system with its 2 little moons, Phobos and Deimos. And they are faintly visible in a sizable backyard telescope, but they're tricky to spot because, they're fairly bright. It's just that Mars is 200,000 times brighter, so the contrast is difficult. But I have seen both of Mars's moons with my own eyes. It's pretty neat. So the Mars system. Mars has remnant magnetism like the moon, which indicates it can't be billions of years old, because even remnant magnetism decays over time. Now, those 4 planets we've looked at are called terrestrial, meaning Earth-like, because they all are rocky worlds. You could land on them, you could pick up a rock for any of them, and so on. The outer worlds are quite different. We'll start with Jupiter. Jupiter's not rocky, it's a gas giant. It's a ball of gas. It's a huge ball of gas. It's 10 times the size of the Earth in diameter. And that gas is held together by its own gravity. Yes, gas has gravity. You get enough of it, it'll manifest and hold itself together. So there you go. You can't land on Jupiter. There's nothing solid to land on. It's gas. It probably becomes liquid at some point. It's compressed into liquid, but there's nothing solid to land on. So that's what it looks like. It always has those beautiful features. Those are clouds in the upper atmosphere of Jupiter that form what we call belts and zones. Belts are dark, zones are light, and the zones are zones are higher than the belts. And of course, there's that great red spot, which astronomers call the Great Red Spot, and it's basically an enormous hurricane, or anti-hurricane, I guess. It's a high-pressure system that's rotating. Now, on Earth, hurricanes, they get their power from the ocean. The heat of the ocean is what powers hurricanes, okay? And in fact, when a hurricane passes over a section of the ocean, the temperature of the ocean there drops by 10 degrees. Now, what happens with a hurricane on Earth is they move over land, and they get cut off from their power source, and they kind of peter out, right? On Jupiter, there's no land. And so that red spot, that hurricane, has been going on for at least 300 years since we've had telescopes powerful enough to see it. And it might have been there since creation, for all we know. Now, it changes size a little bit. It is shrinking, but we don't know if it'll grow back again. We don't really know. But it's you could drop 2 Earths right in that red spot. That's how big it is. So Jupiter itself, about 10 Earths across. An amazing world to look at. It will develop other storms too. I've seen little black storms that have developed on Jupiter. It's wonderful to look at. It never looks quite the same way twice because the cloud features are dynamic. They change with time. Jupiter indicates that it's nowhere near billions of years old in many ways. One is it has an incredibly strong magnetic field, much stronger than the Earth's. And as I mentioned earlier, magnetic fields decay with time. And so if Jupiter were really billions of years old, the magnetic field should have decayed away a long time ago, but it hasn't. Also, Jupiter gives off more energy than it receives from the sun. It gets 1 unit of energy, gives away 2. It emits twice as much as it takes in, and it can't do that forever. Otherwise, the energy would have run down billions of years ago. So basically, it's warmer than it would be if it were billions of years old. It's relatively cold, but it's warmer than it should be if it were billions of years old. So there you go. So there's the Jupiter system. Jupiter has a number of moons. It has, in fact, 70 moons that we know of, 70. 4 of them are large. The rest of them are very small. The 4 large moons were discovered by Galileo in the year 1610 in January. And let's take a look at these because they're wonderful. The innermost of the big 4 is called Io or Io. And I love Io. It is the weirdest looking moon. It reminds me kind of a pizza. Isn't that fascinating? Or maybe an orange that you left in the refrigerator and forgot it was there. And yeah, it's just weird looking. If you've ever been to like the geysers, maybe Yellowstone, if you've been to Yellowstone and you've seen all those geysers, they have a similar coloration because it's similar chemistry. Io has a lot of sulfuric compounds on its surface, and that's what gives it all those weird colors. You won't see an impact crater anywhere on Io because it's the most volcanically active world in the solar system. All those little spots you see there are volcanoes, and they are very, very active. When Voyager 2 flew past Io in the 1980s, it saw 9 volcanoes going off at the same time. So really impressive, this little moon. And that indicates it has internal heat. And internal heat can't last billions of years. And so that would suggest that Io is nowhere near billions of years old because it still has that internal energy. Io is about the same size as Earth's moon, maybe just slightly larger. But the color on it's just wonderful, and it kind of makes me feel like we got ripped off on our moon because our moon's very gray. But Io is very, very colorful and very pretty. And by the way, you can see Io casting its shadow on Jupiter there. That does happen from time to time, and you can see that in a backyard telescope. You'll see this little black spot on Jupiter that over the course of an hour or so will move across the surface as the moon orbits Jupiter. So it's fun to look for those. They're pretty neat to see. So the next moon out of the big four is Europa. Europa is just slightly smaller than Earth's moon and very pretty. And it's known for having these large scratch marks on the surface, like a big cosmic cat came and just kind of swiped it. Isn't that interesting? We think those might be geysers, places where liquid water has been blasted up out of the surface of that. We're not sure about that, but it could be. We've seen similar features on one of Saturn's moons, which I'll show you a little bit later on. So there's Europa. Interesting little world. It's made primarily of ices, water ice and other types of ice as well. The next moon out is Ganymede. Now, Ganymede is the largest moon in the solar system, and that's fitting because it orbits the largest planet. Ganymede is actually larger than the planet Mercury, but because it orbits a planet instead of the sun directly, it's a moon. If you could dislodge it from Jupiter and put it into direct orbit of the sun, it would undoubtedly be classified as a planet. It is larger than Mercury. There's evidence that Ganymede actually has a substantial magnetic field, and that's something that was astonishing to the secularists because this thing's only 50% larger than Earth's moon, and so why should it still have a magnetic field? Magnetic fields decay with time, and the smaller an object, the faster they decay. It's the same reason, your little AAA batteries, they run out before the big, remember those old big D cell batteries? They lasted a long time because they're big. So this is a relatively small world. It's smaller than the planets except for Mercury, and yet it has that distinctive magnetic field indicating its youth, indicating it's thousands of years old and nowhere near billions of years old. And then the outermost of the big four is Callisto, and it's interesting because it has these little white craters all over its surface, pockmarked with little white craters. Quite pretty. So those are the inner moons of Jupiter. Now the inner moons of Jupiter, and there are four that are interior to Io as well, but they're all small. They all orbit in the same direction and in the same plane. You can kind of see that there. They're nice and organized, and that's a design feature because there's not a lot of space available that close to Jupiter, and therefore they need to have that organization so one moon doesn't come too close to another one and either collide or get kicked out by the gravity of the other one. So that's a design feature. But the outer moons, because they're much further away from Jupiter, they kind of do what they want. And if we speed up time, you can see that the inner moons all orbit in the same direction. The outer moons, most of them orbit backwards, interestingly. Now, it looks like a mess, but each one of those is its own perfectly good elliptical orbit. It's just that they're all in different planes. They're all in different directions. You can see the inner moons really whipping around there in the center just to get the outer moons to move. And the outer moons are not in the same plane either. If we look at it from edge on, the inner moons all in the same plane. The outer moons kind of do what they want. And that's a design feature because there's plenty of space available out there. It looks crowded, but it's actually, we're talking millions of miles out in space, and these moons are tiny. They're the size of a large boulder, a few miles across, some of them. So we're going to find that's a common design feature in our solar system. So that's the Jupiter system. Everybody's favorite to look at in a telescope would be Saturn because it has that beautiful ring system. There's Saturn. Let's set it to the current position, the current time. That's what it looks like today if you were to look at it in a telescope. And it's got those lovely rings. Saturn's really pretty similar to Jupiter. It's about 9 Earths across. It's a ball of gas. You can't land on Saturn. There's nothing to land on. It's just gaseous and probably goes liquid at some point. And then you have those beautiful rings. The rings are trillions of tiny little moonlets that orbit around Saturn's equator. And so many of them, they blend together and form those lovely rings. So it's pretty spectacular. And it's very fortunate that God tilted Saturn, because remember, in the secular view, if the planets all formed from a collapsing nebula, they all ought to be upright. They shouldn't be tilted. I'm very delighted God tilted Saturn, because if he hadn't, it would be very difficult to know the rings are even there, because they're very, very thin. They're only about a mile in depth, although they're hundreds of thousands of miles across. So now even here, they're betrayed by their shadow, because they're still tilted relative to the sun. But if it weren't tilted at all, you wouldn't even see the shadow of the rings. You wouldn't hardly know that they were there. But fortunately, the Lord tilted that planet so we can see that lovely ring system. And it really is pretty spectacular. It just looks amazing in a telescope. It's small, but you can see the rings very distinctly. It's very, very pretty. There's a famous picture of Saturn where it's in a crescent phase, kind of like that. And I don't think most people realize the significance of that. You cannot see Saturn in a crescent phase from Earth. Saturn always appears either full or gibbous from the Earth. You can't see it in a crescent phase because in order to see something in a crescent phase, you have to be farther from the sun than the object, because it's all based on the angle between the sun, the object, and your eyes. And so the photograph that looks kind of like that is proof that we've been there. It's proof that we've actually sent spacecraft past Saturn. That's the only way you can see it in a crescent phase. So that's kind of fun to know that. Saturn, like Jupiter, gives off more heat than it takes in from the sun, and it's got a strong magnetic field, just like Jupiter does. And that indicates that it can't be billions of years old because magnetic fields decay over time. They just don't last that long. Saturn has a number of interesting moons. In fact, at the latest count, it's got 72 moons. So it currently holds the record. Jupiter and Saturn, they keep leapfrogging past each other as we discover more moons on one or the other. One of the ones I think is really pretty is Enceladus. It's a very bright white, snowy white moon. It's made of ices. Ice, astronomers, when they talk about ice, it doesn't necessarily mean water ice, but anything that would be gaseous at room temperature, like methane or ammonia, or water, where water would be liquid, those are ices. And so there's Enceladus. And it has these large scratch marks, a bit like Europa, orbiting Jupiter. And we know these are geysers because we've seen them erupting. They actually spray water out into space. And yet this moon is only a few 100 miles in diameter. It's not that big. But the fact that it's able to have these geysers indicates it has internal heat. And that means there's no way it can be millions of years old, let alone billions, because it would have run out of heat billions of years ago. Anytime you have an object that far away from the sun that still has internal energy, that means it can't be billions of years old. So Enceladus is a great example of that. Let's see, what's another moon? Well, we won't do all the moons, obviously, but maybe Titan. Titan's Saturn's most famous moon. It's orange, really weird. And that's because it has a thick atmosphere of hydrocarbons. So gasoline, for example, is a hydrocarbon. So gasoline would be really cheap on Titan because it's kind of what it's made of. But on the other hand, oxygen would be expensive, so count your blessings. You can't breathe on Titan. For a while, they thought it was the largest moon, hence its name, Titan. It's actually the second largest. Ganymede wins. Titan looks a little bigger than it really is because of that puffy atmosphere. Okay, it's kind of like a cat when it gets upset and puffs itself out to look bigger. But if you remove the atmosphere, and we can do this now because we've sent spacecraft, the Cassini spacecraft went into orbit around Saturn and occasionally would come close to Titan and was able to use radar. Remember, radar can go through clouds. So we know the surface of Titan looks like that. Very interesting. Titan actually has oceans of liquid methane. Interesting. So it's the only other object we know that has liquid on its surface. Not liquid water, but liquid methane. And that was a surprise too. Astronomers were expecting to find liquid ethane, not methane, but ethane. That's different. Why? Because methane, when it's exposed to ultraviolet light, is eventually destroyed. Some of it's converted into ethane. And so the fact that you still find methane on Titan is irreconcilable with its secular alleged age of billions of years. The methane should be gone. Because if Titan's been sitting there exposed to the ultraviolet light from the sun for billions of years, ultraviolet light destroys methane. But it's full of methane. So that's just another indication that it's nowhere near billions of years old. It's consistent with the biblical age of a few thousand years. And because of that thick atmosphere, you can see this moon in a small telescope. You can probably see it maybe in binoculars if you got a good set of binoculars. It'll look like this little orange star next to Saturn. It's so weird to see that because it's the only orange moon that we know of. That's pretty neat. Another moon of Saturn that's kind of interesting is Iapetus. Iapetus orbits further out than the others. And when it was first discovered, astronomers found they could only see it when it was on the right side of Saturn, not when it was on the left side of Saturn. That was weird. Does it have like a cloaking device? I mean, how does it do that? Well, there's a reason. Iapetus, like all large moons, rotates at the same rate it orbits around Saturn. And so when it's on the right side, you see one side of Iapetus. When it's on the left side, you see the other side of Iapetus. And one side is bright as snow. The other side is dark as charcoal. Interesting. So it has a light side and a dark side, like the Force or an Oreo cookie. Pretty neat. And we think that's because you can tell the ice is on that side, but we think this side, the dark side, is collected material from another moon that's further out, that's ejecting debris, and the debris collects on the forward side of the moon as it moves forward in orbit. So there you go. You can see Saturn in the background. Iapetus is the closest moon to Saturn that does not orbit in Saturn's plane, in the ring plane. And therefore, if we were to set up on a base on Saturn, that's where I'd put it, so you could enjoy Saturn's rings, right? Because if you're on any of the closer moons, the rings are edge on, you don't see them, at least not well. Iapetus would have a lovely view of Saturn's rings. Isn't that gorgeous? Now, the inner moons of Saturn, like Jupiter, they all orbit in the same plane in the same direction. And again, that's a design feature. There's not a lot of space available that close to Saturn, so they all go the same way, in the same plane. It keeps things organized. It avoids collision. It avoids close passes where one object might get kicked out by another one. But as with the Jupiter system, the outer moons do what they want. A lot of them orbit backwards. They're not necessarily in the same plane. Isn't that interesting? Looks very chaotic, but it's actually very organized because there's so much space available out there. They can have different orbits. They're all perfect ellipses. They're just randomly oriented. So that's the Saturn system. Now, amazingly, in the 1980s, the four giant planets, Jupiter, Saturn, Uranus, and Neptune, formed into a perfect arc. It was gorgeous. And that doesn't happen very often. But by divine providence, it happened at about the same time that technology developed where we could start sending stuff out into space. And that arc allowed us to send one spacecraft out past Jupiter, slingshot it onto Saturn, slingshot it onto Uranus, slingshot it onto Neptune. So Voyager 2 was able to visit all four of the large planets in the outer solar system because of that beautiful alignment that occurred in the 1980s. And that doesn't happen often. You won't see that again in your lifetime. So that's why we're able to have these wonderful images of Uranus, for example. So that'll be the next planet out, Uranus, as it was viewed in the 1980s, 1986. January of 1986 is when Voyager 2 flew past Uranus. Now, the planet Uranus rotates on its side, so it rolls around the sun. Kind of neat. And it happened to be the case that when Voyager 2 flew past Uranus, it flew the North Pole. Well, it depends on how you define the North Pole, but the North Pole was pointed right at the sun. So we only have a map of the top part of Uranus, but it's all you're seeing really is atmosphere anyway. They call this an ice giant. It's like Jupiter and Saturn, lots of gas, but it gets compressed into either liquid or probably kind of a slushy ice on the inside. And it has that beautiful blue color. Uranus really does look blue. And you can see this in a small telescope too, if you know where to look. It's very pretty. Sometimes it develops these enormous white clouds. They're stunningly beautiful. But in 1986, it was a clear day on Uranus, and so you don't really see hardly any clouds. There's just a faint few there. Uranus has a number of moons, 5 relatively large ones, all smaller than Earth's moon though. And we won't do all of them, but let's just take a look at the innermost, Miranda, because it's interesting. Miranda looks like it's been broken apart and reassembled. It just looks like a mess, and it has that sort of reverse check mark that you see there on the lower right at the moment. Now, we only know what the northern hemisphere of these moons looks like because they also orbit on their sides. They orbit around Uranus's equator, and so you can see it spinning there. We only know what the top of the moon looks like. We don't know what the bottom looks like. So I think we need another mission back to Uranus to see what the other side looks like. Maybe an orbiter mission. So there you go. So Miranda, Ariel is the next one out. The names of these moons are a little different from most because most moons are named after pagan gods, like the planets. But the interesting thing about Uranus, it was discovered by an Englishman, William Herschel, and in honor of that, they decided to name the moons after Shakespearean characters, England's greatest playwright, either Shakespearean characters or characters from Alexander Pope's The Rape of the Lock. But in any case, interesting. So that's why they have unusual names. Only Uranus has that. Okay, so really interesting world. Has a strong magnetic field. that was predicted by Russ Humphreys back in '84 based on the biblical age of 6,000 years. The secularists were way off. I'll talk about that more this evening. But that strong magnetic field means Uranus cannot be billions of years old. It's an indication of its youth. So that was in '86 that Voyager 2 flew past Uranus. And then in '89, Voyager flew past Neptune. And boy, was that exciting. I remember that happening, and it was just cool because we got to see what Neptune looked like. Neptune's so far away, you can't hardly see any details, even with a backyard telescope. You can see it, but it's a little blue speck. That's all you can tell is that it's blue. And when Voyager 2 flew past, it found these lovely white clouds in the atmosphere along with a great dark spot. We thought Jupiter was the only planet that had that until Neptune. And oh, it's got one too. That's kind of neat. And so that's basically a giant cyclone. It comes and goes. Unlike Jupiter's red spot, which appears to be permanent, the dark spot on Neptune disappears sometimes. We know that because Hubble is able to zoom in on it and see it in pretty good detail these days. And sometimes there's another one that forms in the northern hemisphere as well. So that's the Neptune system. Like Jupiter, it gives off more than twice as much energy as it receives from the sun, which means it can't be billions of years old. And like Uranus, it has a strong magnetic field, indicating that it can't be billions of years old since magnetic fields decay with time. Now, the inner moons of Neptune are all small, and they orbit in the same direction as Neptune. Neptune has a really weird moon, though, called Triton. And Triton orbits a little bit further out, and it orbits backwards. It's the only large moon that orbits backwards. And again, I think God did that just to confuse the secularists. But it orbits backwards, it rotates backwards as well. And the other thing that's neat about Triton, it has these large features. You see those dark streaks on the surface there? Those are nitrogen geysers. Triton has a thin atmosphere, and it has these geysers that shoot out nitrogen, and they carry soot with it. And then the winds carry that soot, and they deposit it in these horizontal streaks. So that's why you see those little black horizontal lines there, and you can see those all over the lower regions of this moon. Now, this thing is quite a bit smaller than Earth's moon, and the fact that it still has geysers on it indicates internal heat. It means it can't be billions of years old, or it would have run out of heat a long time ago. So Triton, that's the only moon you can see of Neptune with a backyard telescope, and just barely. It is very, very faint. So that's the Neptune system. Now, I had to wait on Pluto for a long time. Because when I was a kid, we had, I remember the Voyager 2 encountering Neptune. And I'm like, but what about Pluto? Pluto was not a part of that great arc. Okay, it was in a different direction. And so Voyager 2 was not able to fly past Pluto. They could have sent Voyager 1 that way, but they opted to go past Saturn's moon Titan instead. Big mistake in my opinion, but in any case, because we can go to Saturn anytime, it's close. In any case, in 2006, in 2006, they launched the New Horizons spacecraft. It's about the size of a grand piano, and they kept it small so that they could get it, push it as fast as they could get it. And it took 9 years to reach the planet Pluto, the former planet Pluto. Pluto got demoted, as you know, got Plutoed, okay? And a number of reasons for that, which I won't go into. But Pluto is much smaller than any planet. In fact, Pluto is smaller than Earth's moon. It's only about two-thirds the size of the moon. And that's one of the things that contributed to its demotion. When it was first discovered, they thought it might be the size of Earth. And then they said, well, maybe the size of Mars. And, well, maybe the size of the moon. And then it's pretty small. But fortunately, in 2015, New Horizons flew past Pluto. And I got my child's wish of being able to see what this little world looks like for the first time. So we know it looks like this. Now, when New Horizons was still far from Pluto, it was photographing this side. That's why we don't have this side in such high resolution. Pluto takes 6 days to rotate. So by the time New Horizons got close to Pluto, the really cool side had come into view. And so we have much higher resolutions of this side. This is what New Horizons flew past when it got really close to Pluto. And you got this huge heart-shaped feature, which the secularists were not expecting. The secularists were expecting that Pluto would be a cold, dead world full of craters because there's lots of objects out at the distance of Pluto that could impact the surface. And over billions of years, it should be nothing but a cratered mess. Small as Pluto is, two-thirds the size of Earth's moon, it shouldn't have any internal heat. There shouldn't be any geology, because geology mountains take heat to move the masses and push them up and so on. There shouldn't be any mountains. There shouldn't be any canyons. It should be nothing but craters. Now, there are a few craters on Pluto, But this section right here, which we call a Sputnik Planitia, there's not a single crater there. You tell me that went billions of years and not one object impacted? That's absurd. There's obviously geologic activity there. In fact, you can see that weird sort of, looks like a jigsaw puzzle that's been put together. And we think that's due to convection currents. So that requires internal heat, you see. And there are mountains on Pluto. You can see them here. These things are mountains. They're about as tall as the Rocky Mountains in the United States. And instead of being made of rock, they're made of ice, water ice. At that distance, ice is as hard as rock because it's that cold. And they have a real thin layer of methane on top. That's what gives it the orange color. So interesting. And there are canyons. You can see those canyons. See those? Isn't that fascinating? You wouldn't expect that if it was billions of years old. Those should have been completely covered with craters by now. But that's an indication of the youth of Pluto and the fact that it still has some geology. It still has some internal heat that produces that geology. Pluto has 5 moons. One of them is enormous in the sense that it's half the size of Pluto. It's called Charon. So there's Charon. We got some good images of it as well. And also it has some craters, but it has mountains. You can see the mountains. You can see the canyons on Charon. It's got a dark North Pole, which is something we've never seen before. That's kind of interesting. We're not quite sure why that is there, but it certainly defies secular expectation because it's not just saturated with craters over allegedly billions of years. And astronomers have taken to naming the various features on here. I'll show you this because it's kind of neat. I think this is cool because they named them after sci-fi characters. So you got Vulcan Planum, you got Spock Crater, Kirk Crater, and Uhura Crater, and somewhere there's Skywalker Crater, Ripley Crater. They didn't leave out Lord of the Rings. This area they call Mordor. So there you go. I think that's pretty neat. I don't know if those will catch on, but I hope they do. I think that's neat. So there's the Pluto system. And again, it has 5 moons, but the other 4 are tiny. And pretty amazing that we can do that. We can send spacecraft that far out into space. Pluto's like 4 billion miles away. It's amazing that we can do that. And it reminds us, too, when we see when we take a look at these worlds, they're beautiful, they're interesting, they have lots of interesting features on them, but they're not suited for life. And it reminds us of the special beauty of our world, a world that is designed for life, a world that God formed to be inhabited. And of course, and of all the planets in the solar system, this is the one where God walked, where God took on human form, human nature, and visited and died our death. That's awesome. One of the astronauts who walked on the moon, there were 2 astronauts who walked on the moon who later became Christians. And one of them, I forget which one of the 2, said that the amazing thing is not that man walked on the moon. The amazing thing is that God walked on the earth. I think it's pretty neat. I think it's a nice way to think about these things. So let me show you some of the resources we have. Worlds of Creation, that's this presentation. We have that on DVD back there. And I don't use notes for this presentation, so I never do it exactly the same way twice. So you'll probably get different information on that one than you got this morning. Astronomy Reveals Creation, that's the presentation I'm going to do tonight. If you're able to come back. If you can't come back, you can get the DVD. There it is. Taking Back Astronomy is the book that will go along with the presentation tonight, showing you how the universe declares God's glory, not billions of years, not a big bang. Stargazer's Guide to the Night Sky. This is just a fun resource on how to better enjoy the night sky from a Christian perspective. That's pretty neat. If you ever wanted to know what the constellations were or what's that really bright star and things like that, if you have binoculars, there are star clusters you can see in binoculars if you know where to look, and the book will show you that. If you want to get a telescope, what kind you might want to get, how to use it. But even if you don't have a telescope, a lot of stuff you can see naked eye, like when's the next meteor shower, when's the next lunar eclipse. Next lunar eclipse is coming up pretty quick, next week actually. So the book has that kind of information in it. Created Cosmos takes you on a tour of the universe and then goes all the way back into the Earth at the very end. It's really neat. And that's the planetarium show that I wrote for the Creation Museum in Kentucky a long time ago. And we put that on DVD for you. And don't forget to sign up for our free monthly newsletter. It's an electronic newsletter, so make sure you put your email address legibly or you'll get nothing. So do sign up for that, and that'll just kind of keep you updated on what I'm doing and what we're doing at the Biblical Science Institute. And then do check us out on the web as well, biblicalscienceinstitute.com. And of course, we have our resources back there. We have some children's resources as well. You might want to check those out. So thank you very much. Appreciate it. God bless.